Happy Thursday evening, everyone. I hope you're all doing well today. Welcome to Thursday night LumCon Science Talks. And tonight we have Dr. Abigail Bockus with us. You know that suggestion you brought up earlier, Abigail? It's happening. I'm Jonathan. Hey guys, if this is your first Science Talks, you can engage with us here at home, LumCon at home, by using your question box. If you are familiar with the question box or just want to practice, if you're a first timer, go ahead and send a shout out. Every week I start with just a really silly question for you guys to answer. So here it is for this week. I want to know what your feelings are about ketchup on scrambled eggs. Is it totally should be illegal or is it the best thing on the planet? Let me know what you think. Mary Miller says no, never. Or no.
Yeah, I'm with Mary on this one. Yeah, no, it's not.
Jonathan says, what'd you say? Illegal is what Jonathan
It would just get in the way. It would just get in the way of the hot sauce.
Yeah, that's what I'm thinking.
It's true. It's true. It's true.
Wait a minute, Mert, are you a ketchup on eggs person?
If I'm gonna be totally honest, I used to be, and now, no.
Was it the move to the South?
Actually, no. It just started to be kind of disgusting. You know, when you're in college, you're eating cafeteria scrambled eggs.
Yeah.
You have to
cover up the taste.
That's right.
Since LumCon is a Tabasco family, you have to be careful about what hot sauce you use.
Oh yeah, it's only Tabasco.
Alyssa says with white rice, and I have seen now, and it is actually good. I've actually tried that too. Yep. Oh, Jonathan, pretty catchy. What came first, ketchup or the egg? Well, you know, Jonathan, the egg is potential, ketchup is reality. That's what I have to say. Oh, Arturo's mom's eggs, his mom's eggs do need ketchup. My eggs don't need ketchup.
Oh, so is there like a correlation between the amount of ketchup, whether ketchup's required or not, and the quality of the eggs? I take it.
How about it, Arturo? What you saying there? We won't tell mom.
Sort of like A1.
Ooh. Yeah, definitely the lower.
Arturo says he's a better cook. Yeah. Oh, and he's also saying that Crystal is superior to Tabasco. Sounds like a question we could ask next week.
that's a bold statement there. Yeah.
Absolutely. All right, I'm gonna step off stage and let you guys engage in science, and I will see you at the back end of the talk.
Thanks,
Have
Mert.
a good time.
Thank you so much, Mert. Well, welcome everyone. Good evening. I hope I find you and your family and friends safe and in good health this evening. I'm Craig McLean, the Executive Director of LumCon, and I'd like to thank you for joining us tonight for the eighth talk in LumCon's online science series. Every Thursday night at 7 p.m. Central, we're inviting Louisiana scientists to share their research, and we'll give you the opportunity to listen and ask questions of some truly amazing people doing some truly extraordinary science. And I hope you will continue to join us each week as we explore more of our world from the comfort of our homes. And you can find more information about the complete series at our website, lumcon.edu. Just scroll down on our homepage, the link under the news and events. And I'm happy to say that we're going to continue the series on into August. And so you can see some of those upcoming talks there on our website. Well, tonight it's my privilege to introduce Dr. Abigail Bockus. Dr. Bockus is an assistant professor at LumCon. She got her PhD in biological and environmental sciences from the University of Rhode Island in 2016. At URI, Abigail's research focused on aquatic biology and the impacts of environmental change on marine ecosystem stability. She went on to complete a research fellowship with the U.S. Fish and Wildlife Service in Bozeman, Montana, where she conducted research on fish nutrition, feed formulation and feed manufacturer. And Abigail joined us at LumCon 3 years ago and now runs an active research program there. Her team is focused on promoting global food security through aquaculture innovation and informed natural resource management. And it's with my pleasure to turn it over to Abigail tonight. Looking forward to the lecture. Thank you.
Thanks, Greg. 1 second, guys, while I get this in order. All right, so hey everyone, I'm so excited to be here tonight to tell you a little bit about aquaculture innovation in the United States and what we're doing to expand where we can farm and what we feed these farmed animals. So to kick us off tonight, I actually wanted to hear from you guys. So Mert, can you launch that poll?
Absolutely.
Thank you.
All right, you guys, I'm gonna launch the poll now.
Great, so you guys should see a poll question pop up. And I was really curious to hear outside of my professional network what you guys had to say about. If someone were to come up to you and say, hey, can you tell me what aquaculture is? What would you say? Would you say, oh yeah, sure, launch into it? Would you say, no, I've never really heard of aquaculture, or maybe I've heard of it, but I still don't really know what it is? Or do you maybe know what it is, or sort of know what it is? And while we wait for those answers to come in, so to be totally honest with you guys, aquaculture is something I didn't know anything about until my mid-20s. And at the time, I was actually getting my PhD in oceanography. And when I heard about aquaculture, it completely changed my career trajectory. And now the major focal area of my research program is actually conducting research and development to help the aquaculture industry grow here in the United States. So we might give it a few more seconds and then Mert will share what you guys had to say.
All right, Abigail, the results are in with 89% of the attendees voting. We had 61% of them say, yes, I sure do. 12% said, no, not at all. And 27% said, maybe.
Sort of. So that's really interesting. So whether you've heard about it or not, I hope tonight I can teach you a couple new things. So I think in its simplest terms, aquaculture is just farming in water. And like you have farmers on land, this term doesn't just apply to farming animals, but it also applies to the farming of aquatic plants as well. And my expertise is actually in fish farming, but we have some really great work going on in some of the other major aquaculture sectors here in the US. So we have people working on farming shrimp. Here in the US, we actually have a really large shellfish sector, or a lot of people conducting oyster aquaculture. So here in the top right is a picture of an off-bottom oyster farm up in Washington State. And we have people working on the cultivation of aquatic plants, so things like macroalgae and seaweeds. And depending on where you are and the type of animal you're trying to raise, these aquaculture farms actually look really different. And the sector I want to focus on a little bit tonight is the development of offshore aquaculture farming. So if you look down in the bottom left, offshore aquaculture farms are farms that are placed out in the open ocean. They're usually really large, and they're primarily used to grow high market value fish species. So if you look at this picture, this is an example of a farm that's using surface net pens. So each one of these circles is an individual pen. So you have a floating apparatus on top, and the net hangs down below, and that's where you hold your fish. And depending on the bathymetry or the depth profile of the ocean, sometimes these offshore aquaculture farms are sited up to 30 to 50 miles offshore. So that takes us out of state waters and puts us into federal waters. And these federal waters extend out to 200 miles offshore. And we call this the US Exclusive Economic Zone. And that's what they're showing here in blue. And if you compare the US EEZ to other countries, we actually have one of the largest exclusive economic zones in the whole world. So if you look at that in terms of just raw space, that's a huge amount of development or expansion potential for offshore aquaculture here in the States. And in fact, literally 3 weeks ago, the president signed an executive order outlining some of the ways that we can advance offshore aquaculture domestically. And this was a really huge win for the offshore aquaculture community. And among other things, this outlined having a centralized and efficient permitting and regulatory infrastructure. And this was really beneficial for farmers that want to get pens in the water. We want to make sure that their paperwork isn't held up in the government for 10 years. So historically, when you want to site these farms, you're looking for a really calm, protected area. And a really great example of this is Atlantic salmon farms up in Norway. So these are located in really deep marine fjords. So this makes it, so in these fjords, you have the depth drop off really quickly. So you can site your farm close to land. This makes it really efficient for your personnel to be able to access that farm site, to do routine maintenance or to do feeding. And also when farms are in these fjords, it protects them from dangerous wind and wave activity. So if you're talking about offshore aquaculture development in the Gulf of Mexico, this is just not the case, right? We're living in a really high energy system. For folks that live in this area, as you know, we have a lot of storms, we have a lot of hurricanes. So the big question is, if you put an offshore aquaculture farm in this area, how do you protect that farm? So we have aquaculture engineers that are working on net pen technology. So in these examples, you have fully encapsulated net pens that you can actually submerge. And these are in the form of aquaculture pens, or like I'm showing you here in the bottom right, this is a spherical aqua pod. So not only can you submerge these entire pens, but they're tethered in a way where you can actually raise them up and down in the water column. So if you had a storm coming at you, you could just submerge your entire system, and all that dangerous wind and wave energy would go right over the top of your farm. An area of offshore aquaculture development in the Gulf of Mexico that me and my team are involved in is looking at whether we can use oil and gas platforms off the coast to support an offshore aquaculture farm. So if you go to the northern Gulf of Mexico, we're a really highly industrialized area. So we have a lot of oil and gas production. And off the coast, like you can see here in the red, we have over 2,000 offshore oil and gas platforms. But right now, we're actually seeing a shift in the oil and gas industry. These companies are moving towards land-based production or going towards larger oil rigs in deep waters further offshore. So a lot of these historic or normal platforms on the continental shelf are going out of use and being decommissioned. And this is happening faster than it ever has before. We're seeing about 175 platforms being decommissioned each year. So there's a company based out of Mandeville, Louisiana, called the Gulf Offshore Research Institute. This company is taking decommissioned oil platforms and repurposing them for other multi-use activities. So this includes repurposing them to support things like offshore renewable energy, so generating energy through wind and wave activity, and offshore aquaculture. So me and a team of scientists are working with this company to look at 2 platforms in the southwest Gulf of Mexico to see whether these platforms would are located in a good place to support offshore aquaculture. Where's my pointer? So we're located in this area way down here. And these platforms are just south of Corpus Christi and about 30 miles offshore. And what we're doing right now is looking at whether these platforms are located in a position that could be economically and environmentally compatible for offshore aquaculture. So we have an economist on board from Louisiana State University, and he's looking at whether a farm could be profitable if it's placed in this location as either a standalone operation or whether you co-site offshore aquaculture and renewable energy. And we're also doing a lot of work to look at the environmental compatibility of this location. So when you site an offshore aquaculture farm, it's not random. A lot of considerations go into where you want to put that farm. And our partners at NOAA have built a really invaluable resource. So they've taken 170 different data types and they've mapped them across the entire Gulf of Mexico. So this lets us go in and look at where are things like the major shipping channels. So we need to avoid those to avoid ocean user conflict with other ocean user groups. And things like where are sensitive bottom habitats like coral hard bottom. We want to make sure we protect those environments and site our farm in a way that they won't impact those environments. And a third type of data they have is environmental data. So it lets us look at things like what is the temperature throughout the year and what is the salinity throughout the year, and how can we use those data to help us choose what sort of fish species might do well in a particular area. What's really cool about all these data is the NOAA group has actually built a really user-friendly interface. So if you're interested in visualizing some of these things, you can Google the Gulf Aquamapper tool or go to this link and you can pull up a map just like this, and you don't have to know anything about mapping. And you can select what sort of variables you want to map. And in the screenshot I'm sharing with you guys here, I've just mapped the shipping lanes, which are shown in green, and those sensitive coral hard bottom habitats. So our NOAA partners are sharing all those data with my group, and we're going to look at the Station Padre site to see if any significant ocean user conflict is occurring there and what the environmental conditions are for an offshore aquaculture farm. And I really can't overstate how important all this data has been. And so this is like a phenomenal resource, not only for our group, but for anyone interested in siting an offshore aquaculture farm in the US. And they first targeted the Gulf of Mexico, but they're building similar databases for both the Pacific and the Atlantic coast as well. So to round us out today, I want to switch gears. We talked a little bit about systems, but now I want to talk about one of my favorite areas of development, which is aquaculture feeds. So let's talk about what we're actually feeding these animals. So for the majority of animals that you culture, you're going to feed them a flaked or a pelleted diet, like you're shown here, sort of like what you might feed a dog or a cat. And the composition, or what makes up that pellet, is actually really complex. So here on the left, I'm showing you the typical ingredients, or what we call a formulation for a fish diet. So like you can see, there's a lot of different ingredients that go into that, and which ingredients you put in and how much of those ingredients you put in change depending on the type of organism you're talking about and where that organism comes from. So if you're talking about a marine fish, that diet's going to look different than if you're talking about a freshwater fish. And one of the major ingredients in all these diets is a source of protein. So today we're going to focus on where that protein comes from and what we're doing to increase the sustainability and the digestibility of that protein. So in most of the commercial diets that you'll see, that protein actually comes from wild caught fish. These fish species are usually species that aren't great for human consumption. So this picture here in the middle, this is an adult menhaden fish. It's really small. So if you were to fillet that for dinner, that's not going to be great for the dinner plate, right? So these are either small fish, maybe they're really bony fish or really oily. And so we take these fish and we process them into what we call a fish meal. So this is almost like a powder, and fish meal has a lot of protein in it. So you take the fish meal and you put it into your diet, and that's your protein source. So when you want to store fish meal or transport it, you end up with really big piles like this. And back in the day, they were actually having problems with these piles randomly catching on fire. This was such a big problem that it was actually sinking ships in transit. And they discovered that what was going on was that the fatty acids in the fish meal were reacting with oxygen and causing heat. And if you had big enough piles that were dense enough, this heat would start fires. And once they discovered what the chemical reaction was, they found that if they added antioxidants into their fish meal, you guys might recognize this word. These are beneficial substances that you see advertised in the grocery store sometimes. So if they took antioxidants and put them in the fish meal as well, it stopped this reaction and problem solved. So I thought this was a really fun example of one of the early innovations that were being done in, feed ingredient formulation. And most of the commercial fish meals you'll find now all have antioxidants added into them. So where we're at now is we have maximized the amount of fish meal that we can harvest from traditional sources. And so as the aquaculture industry grows, we're looking for other places to get protein. So we want these other sources to be sustainable, and we want them to be cost effective. And so one of the things that folks are looking at are other fish species. So if you look here in the top right, this is a picture of Asian carp. This is a freshwater fish species. It's super invasive. You can find it all up and down the Mississippi River Basin. And this fish proliferates really rapidly and can be really damaging to native habitats. So we have a group in Colorado that's looking at using Asian carp as a source for fish meal or a source for protein. So that will not only protect some of these environments by commercially fishing down those populations, but then preliminary research has shown that it's actually a really digestible source of protein. We also have a group in Louisiana that is building a brand new processing plant, and they want to harvest Asian carp and take the fillets and turn them into these really yummy fish cakes. But when you take the fillets, you're left with a lot of the fish left, okay, sometimes over 70%. So you have the head, you have all the guts, or what we call the viscera, you have bones, you have skin, and instead of throwing that away, there's actually really valuable nutrients and minerals in those fish components as well. So what we want to do is work with this group to look at the nutritional quality of some of these products and see if we can keep processing them or render them into additional products that can either be put into aquaculture feeds or used for other things. Another big incentive or place that we're looking to develop protein alternatives is using single-celled organisms. So sort of like, or organisms such as bacteria and microbes. So there's a company in California that's taking industrial waste CO2 and using that to feed bacteria that are housed in a bioreactor. Then they take those bacteria, they condense them, they process them, and they can actually turn that into a protein source or a protein meal. So this company is literally taking pollution and turning it into food. Another source of proteins that people have been looking at for a really long time is removing fish-based proteins from the diet and replacing them with plant-based proteins. And a plant that seems to be doing really well as a protein source is soybeans. Now, the problem with using plant-based proteins is some fish species, especially carnivorous fish, are really bad at digesting plant-based material. And the reason for this is plant materials have really high levels of these compounds we call anti-nutritional factors, or ANFs. And when fish consume these ANFs, it damages their intestine. So it changes the shape of the intestine and causes a lot of inflammation. And this makes it so the fish are really bad at digesting their food. So in this top picture, I'm showing you an example of a happy, healthy fish intestine. And this is a microscopic cross-section of the intestine. And then down below, this is a fish that is experiencing those problems digesting the ANFs, and we call this enteritis. So as you can see, the shape of the intestine is really different, and there's a lot of inflammation going on. So there's a lot of things that scientists are trying to do to combat this problem, right? So we have scientists that are breeding plants to have really low levels of ANFs. We're also having people that are taking non-selected plants and processing the feed or the feed ingredients. So if you process those pellets, you can sometimes remove or degrade the ANFs so they don't cause these problems. We're also looking at whether we can add other feed ingredients into the feeds to combat some of these problems. So when I was learning about all of this, I was actually just wrapping up a study looking at how fish have evolved to live in the deep sea. So as you travel down in the ocean, you have this increase in hydrostatic pressure. So if you've ever jumped off a diving board, maybe gone a little too deep and felt that pressure in your ears, where these fish are living down at 6,000 feet, it's like that pressure, but times 200. So they've evolved really cool ways to help their proteins maintain their shape and function. And one of the main things they do is accumulate this really small molecule in their cells called Tmao. And what Tmao does is it interacts with water and it interacts with proteins in a way that helps the protein maintain its shape and helps it do its job. So Tmao is not a special thing that you only find in deep sea fish. You can find it in humans and you find it in plants as well. And so I also knew that Tmao didn't only stabilize proteins, but it actually stabilizes the membranes of cells as well. So from what I knew about this, I was wondering if we take this small molecule that I've been studying in deep sea fish and we put it into an aquaculture feed, can that molecule help the intestine of the fish maintain its shape and help it do its job? So that's what we did. So we took Tmao and we put it into the feed of rainbow trout. And the first question was, can these rainbow trout even digest it from the feed and accumulate it? And when we looked at that, so if you look here, the more Tmao we put in the feed, the more Tmao we saw in the fish tissue. So that's great, right? They can digest it from the food. And then we wanted to go in and look at whether it was helping the intestine maintain its shape and do its job. So this process of changing shape and getting inflamed, or what we call enteritis, is really well described. So we know a lot of different characteristics that change, and we can rate them on a scale of 1 to 5, 1 being happy, healthy fish intestine, and 5 being severe enteritis. So when we went in and looked, what we saw was when fish were fed protein from other fish, like we expected, you have a really happy, healthy fish intestine. When you take out that fish protein and put in plant-based protein, we saw a lot of inflammation. Okay, we saw enteritis showing up. This is a problem. And when we added Tmao at a certain concentration, it could actually help that intestine maintain its regular healthy shape. And when we looked into the genetics of it, we also saw that adding Tmao into the diet suppressed inflammation or suppressed the expression of these inflammatory genes. So this was really exciting to see, but to conduct this trial, we bought Tmao as a chemical from a company, which is super expensive to do. So now we're looking into the levels of Tmao in feed ingredients that you can already buy. And we found some that have significant levels of Tmao. So the next step is to look at how do we get Tmao into the diet from commercially available ingredients. So how do we make this cost effective? So that was just sort of a quick and dirty overview of some of the expansion potential of the aquaculture industry and some of the system and feed technology developments that we're seeing. And through all these things, aquaculture is actually the fastest growing food sector in the whole world. And really, it's just an exciting time to be part of it. So with that, I would love to stay on and talk about any questions or comments you guys might have.
Great, thank you, Abigail. And we got questions just pouring in, so I'll eat up a couple of seconds while people are just typing away. If I could get you to stop sharing your screen. There you go, perfect. Yeah, lots of questions, so I hope you're ready.
Okay.
For those of you out in the audience, if we don't get to your questions today, I really do apologize, but we'll get to as many as we possibly can. So the first question is from Lauren. Lauren is asking, since these aqua farms are limited in movement, would these farms result in a concentration of waste and an increase in disease susceptibility?
Lauren, that's a fantastic question, and something that people interested in aquaculture are talking a lot about. So especially for offshore aquaculture farms, we're really concerned with how the waste might impact mostly the benthic or the bottom habitats. And something that I didn't talk a lot about, but is part of that study I told you about that's happening down south at Station Padre, is we're going out in July to measure the currents. So what do the surface and underwater wave currents look like in that area? So what that will tell us is where is the waste from the farm going to go and how much is that going to disperse? So we're going to look at the direction of the current, the speed of the current or the velocity, and that will also help us determine where to site the farm. And I'll also say that there are regulatory landmarks that we have to meet in order to put a farm in the water and then to continue to assess that impact on the environment. And so environmental health is really important to aquaculture developers and something that is worked into the planning and regulatory process before and during.
That's great to hear. Thank you for that. Jonathan's question is, do you run into any ethical problems or political hurdles in fish farming or shrimp farming?
Great question too. People are just like really throwing them at me. So this is actually one of the big pushes why the US should be developing its own aquaculture. I didn't have time to talk about it, but almost all of our seafood is imported and half of that is already being farmed in other countries. So if we develop our own aquaculture farming, we set our own regulations. So we don't have any say over how those farms operate or what those farms are doing. But here in the US, we have really strict rules about how we treat those animals, and what we're allowed to do. So for example, we have really strict regulations about the use of antibiotics in aquaculture. I'll also mention that from a how are we treating the animals perspective, if your fish are stressed out, they're not going to grow well. And as a product, that's bad, right? Because you're going to end up with smaller fish, less feed efficiency. And so it's really in your best interest to treat your animals well and not overstock, and make sure you have healthy, happy animals.
Perfect, thank you. Genevieve is asking about sorry. I'm losing my words and they're right there. Oh my gosh. Mycotoxins, a problem in aquaculture feed in the same way as animal feed.
Yeah, I'm sorry, I don't know anything about mycotoxins. So super great question. For things that I can't answer, I would love to have people follow up via email. I would love to continue the conversation. So you can find my email on LumCon's website if you ever want to talk more about it. But that's not, I've heard of mycotoxins, but I don't know anything about them. Sorry about that.
No problem. It's nice to hear a scientist say, I don't know.
Yeah, sure.
It happens quite often.
May not be the last one, yeah.
Karen has a question about snakeheads and if northern snakeheads could be used for protein in fish food.
Yeah, so most of this fish meal is coming from marine fish species. And when we're looking at things like Asian carp, which is a freshwater fish species, the composition of that fish is a little bit different, but generally is still pretty comparable. And so other animal-based proteins usually do pretty well with slight differences, but.
Great, thanks for that. Christopher has a really interesting question and has to do with plastic pollution. So his question is, how does or do plastics play a role in aquaculture? What is the effect of plastic pollution on fish food production? Because big fish eat little fish and little fish incidentally eat plastic.
Yeah, so I feel like this new research emphasis on microplastics and things like that, to me, is relatively new. The last 5 years, it's really exploded. So I'm not aware of studies that have looked at that transfer up the food chain into aquaculture, and it might be that I've missed it, but I haven't seen those studies myself. And I know this is a little off topic, but since you bring up the food chain, right, we have, plastics, little fish, the whole food chain. Another initiative that we're looking at in terms of where are we getting these feed ingredients? Instead of having a really long food chain, if you're taking plants and feeding them directly to big fish, you're cutting down that food chain, and that's more efficient. So you're actually saving energy transfer that way.
Perfect. Helen, hey Helen. Helen's got a question about plant-based protein, and she would like to know, do you know if anyone has checked the protein values of invasives like hyacinths or kudzu for fish food?
I don't, but I'm really interested. So people do a lot of work on seaweeds or macroalgae for protein as well as a protein source, as well as phytoplankton. And generally, they're really promising. And I'm a little more familiar with macroalgal work going into biofuels, but I think algae do really well in aquaculture feeds.
Great. Next one's from Tally, who is asking, can Tmao be integrated into aquaculture as a long-term goal for sustainability?
That's a really interesting question. I'm also so glad someone asked about Tmao because I actually did my dissertation on Tmao, so I know more about Tmao than anyone, or anything I'm talking about. So it's a really interesting question. So we saw that it helped. And we've found it in certain processing byproducts. So not to get too gross, but when you make fish meal, you have a fish, or you have lots of fish, you cook them, you squeeze them, and you end up with this dry powder at the end, which has a lot of protein. But these other parts, you have fish oil that you separate out, which is a great fat source, and then you have this water component. And in the water component, you can actually sell it as a product. It's called fish solubles. You can buy it and put it in your fish feed, and it has a lot of benefits. And some fish solubles have Tmao in them. So now we're sort of exploring, are fish solubles a way to get Tmao into the diet at a commercial scale? One of the drawbacks is we saw that Tmao helped, right? We saw that it helped the intestine, and we saw that it suppressed inflammation, which is one of those big signs of enteritis. But it didn't actually help the fish grow any better. So at sort of those higher levels of organization, like feed efficiency and growth, we didn't see a benefit during this trial. I will say that I conducted this feed trial with freshwater fish, and I wish I had done it with a saltwater fish, because marine fish naturally accumulate or have evolved the mechanisms to accumulate Tmao really, really well. So if I were to redo this, and hopefully I get the chance to, I'd probably choose steelhead trout raised in saltwater instead. And we could see something a little different.
That's awesome. Yeah. Let's do that.
Growing pains.
By let's, I mean you. Kyla has a question. Let's see, I just lost it. Oh, one job, Abigail. One job, and I'm failing at it today. Kyla's asking, can the new pots that you discussed earlier in the talk be used to help filter water, help with pollution or oil in the water?
The new what?
The new pods, the containment.
Sorry, can you ask the question one more time? Now that I know we're talking aquabots.
Yep. She's asking if the new pods discussed earlier in the talk can be used to help filter water, or help with pollution, or help with oil in the water.
I wonder if they mean filling them with something else. Super interesting question. I don't know if I can answer the question, but it makes me want to talk about things like water use in agriculture. So we didn't talk about tank-based aquaculture, but in these tank systems that I didn't talk about, we're constantly recirculating the water through systems that are cleaning the water. And so you can reuse over 90% of that water. So it's a really low water input way to grow food. And when you're talking about offshore aquaculture, it's not zero water input because you're putting water into growing the food, the feed ingredients, but it's also a really low water input form of agriculture because you're out in the ocean.
Yeah, Kyla just sent, she sent in clarification. She meant the pods that you put over the farms. I think it was one of the images that was really early in your talk.
Yeah, maybe I wasn't, I might have not been clear. I think the aquapods that I was talking about actually hold the fish. So it's a type of submersible cage that's fully encapsulated, and that's what actually holds your fish. I don't know if there'd be a way to circulate it in a way that would. So something I have seen done is you can have either a farm pen that you're operating at the surface or at depth, and below it you can have something that thrives off of fish waste. So you can either pair a fish farm with something like a seaweed farm, or like an oyster farm where it's filtering that water and actually thrives off of those excess nutrients. Or I've seen people look at culturing shrimp below a fish farm. So shrimp eat everything, they eat detritus, and then the shrimp are thriving off of that fish waste. So there's systems like that. We're also minimizing our environmental impact.
That is so awesome.
Yeah.
That's so awesome. Becca has a question about what the current breakdown of farm raised versus wild caught fish in the United States is, and how could she tell what fish is sustainable or environmentally friendly to consume?
Sure. I don't know the percentage breakdown in the United States. Like I said, globally, right now we're about 50-50. So half of your seafood is being farmed and half of it is coming from wild caught populations. The percentage here in the US, we're a little behind the learning curve. So we're sort of still in our development phase. And so it's gonna really depend on what sort of animal you're talking about. If you ever eat a tilapia, it's farm raised. Our oyster aquaculture is pretty far ahead of, let's say, our marine finfish aquaculture. But we do have a lot of aquaculture going on that's actually used for something called stock enhancement. So if you're in an area where the natural population isn't doing very well, you'll get these hatcheries that are aquaculture that raise fish or whatever it is up to a small size, and then they release it into the wild to help that natural population. But I'm not 100% sure on the percentages for food consumption.
Gotcha, thanks. It's time for a Ross question.
Hey, Ross.
Ross questions. Ross is asking, do feed ingredients play a major role in determining the flavor, taste, and texture of a fish in an aquaculture setting?
They can, for sure. So in a lot of these feeding trials, people will actually add taste test components to them. So they'll have, I think, professional taste testers come in and score the taste of the fillet to make sure you're not having any flavor issues. Something that's done a lot with with Atlantic salmon as well is adding ingredients to make sure that that fillet has that nice red look that you want. And one thing that you can add to do that is this compound called astaxanthin.
Here's an interesting question from Edward. Edward would like to know your thoughts regarding the use of insect protein in fish food.
Yeah, so man, I wish we could talk about this forever. So something I didn't get to talk about is another major protein source that people are looking into is different insect meals. And I think this is super interesting. In the trials that I've seen, those protein sources do pretty well. Like the fish or other organisms are pretty good at digesting those protein sources. From like a commodity standpoint, like how available is an insect meal, I don't know the answer to that. So since that is also sort of a developing industry, that's something we also have to consider is, can we actually get our hands on these ingredients? So it'll be interesting to see how that changes over the next, let's say 10 to 20 years as, insect culture, let's call it, sort of takes off.
Awesome. Jamie has a really, watch out. Anyway, Jamie's got a question about hypoxia. And the question is, what is the annual flux in the hypoxic zone development? What about the annual flux in the hypoxic zone development in the Gulf? How would this be managed or mitigated with enclosed fish camps?
Ooh, tricky. Okay, so for people that don't know, I feel like we should explain what that is real quick. So off the Louisiana coast, you have the Mississippi River dumping out into the Gulf of Mexico. And off the coast, every spring to summer, you get this huge region, so think like 40 miles long plus, of really low oxygen that develops near the bottom and sticks around for months. And the development of the dead zone is really complex. And one of the scientists, one of like the major scientists who's been describing it her whole career is Dr. Nancy Rabelais, and she's actually LumCon faculty. So I almost don't even want to talk about it. But if you are siting a farm, I would say you need to avoid that area, because if you have a development of low oxygen, it's going to hurt your farm. It's going to hurt your fish. In terms of how farming could impact the dead zone, one of the contributors to the development of the dead zone is nutrient runoff from the Mississippi River. And a lot of that comes from things like terrestrial agriculture and fertilizer. And so I guess in the aquaculture community, just considering the environmental impacts of things like our feed ingredients is where that would come into play in our world, and is really important.
Perfect. So we had a clarification on Lauren's question about mycotoxins.
Okay.
And then the clarification came from Tyler, who says mycotoxins are, and for those of you out there who don't know, these are fungal toxins, so toxins produced by fungi, are a major issue for farms that don't store their feed properly. Every farm needs a ventilated, air-conditioned feed storage area, or else it will spoil, and mycotoxins are one of the prime offenders. So thank you, audience, for that, especially Tyler.
Totally.
Thank you so much.
I'll throw in now that I know what it is, I'll throw in a little bit tidbit too. So for some of these feed ingredients, they found that if they acidify it, so your pH range is 0 to 14, neutral is 7. If you acidify your diet, it actually stays on the shelf better and longer, and you don't have some of these contamination issues. And so something that people sometimes do is acidify their feeds, and then the shelf life is longer. I actually have a study going on right now about what the pH of the pellet does to digestion. Sometimes it can be good and sometimes it's not. So figuring out why that is something that we're working on right now.
Perfect. There's so many questions. I'm sorry. They just keep coming in.
Shoot me the easy ones, girl.
Man, I can't read them fast enough. Here's a TMAO question just for you. Are there any side effects to excessive TMAO in fish, or do the benefits level off at a certain point?
Yeah, I feel like I was just watching a documentary recently. What's it called? Game Changers. Okay, doesn't matter. Anyways, yeah, so there's been a lot of work done on TMAO in humans, and people have been saying that it could be linked to cardiac disease. And how it works, since it stabilizes proteins, if you have too much of it, you can actually have all those proteins start aggregating or clumping up together. And so, yes, too much TMAO can be a problem. But at the levels we tested, I would highly doubt that's the case, because, like I said, we were dealing with this freshwater fish, and the levels we were seeing were way below what you see in marine fish. So I doubt the evolution would be so different that they would respond so differently to those levels. But yes, too much of it is definitely a bad thing.
Very good. Arturo has a question about predators. And his question is, what measures are taken to deter predators, and what measures are taken to protect predators in an aquafarm situation?
Yeah. Marine mammal entanglement is a huge focal area. I'm not directly involved in it, but I know people that are siting and developing not only where we put these farms, but the actual pen technology and tethering systems and things like that, are really aware of whether or not that's causing a problem for marine mammal entanglement. And I've heard of things like putting sensors on cable lines so that if that were to happen, you would be notified, right? So that's an area of research that's happening to make sure that we're protecting some of those larger animals. In terms of predator interactions with the farm, your fish are pretty protected in these systems. But something I've heard about, so we have offshore aquaculture farms in Hawaii, and these farms do attract other types of wild animals, and they've actually found that their recreational fishermen love it. So it's a really good place to bring your clients, get a good catch.
That makes a lot of sense. Makes a lot of sense. The next question is from Aaron. Aaron's question is, I imagine that an IMTA system of fish and macroalgae would help with hypoxia or anoxia in the Gulf of Mexico.
Super interesting question. Yeah, if you, interesting. So I think what they're talking about is when you have plants, instead of taking up oxygen, they're releasing oxygen, right? And so could you do something with culturing a lot of algae or plants to sort of counteract the negative effects of developing hypoxia? Which is really interesting. I mean, I would love for someone to sort of balance out that give and take to see if something like that would be feasible. I think it's really interesting. I would still be concerned that siting a system that close to something that develops so regularly would just end up damaging the system. But I think it's really interesting.
Absolutely. Here's another very interesting question from Ron. Ron is asking, can aquaculture reduce the risk of human disease, such as hepatitis, when you're talking about oyster aquaculture?
Good question. I don't really know how to answer this. I'll say that, of course, there are things like adding seafood to your diet is generally beneficial for your health. So there's a lot of benefits of eating seafood or eating fish on a regular basis. And I'll also say that I'm not part of the oyster community, but I know that people that are farming animals like oysters are really conscientious to make sure that they aren't introducing disease by humans consuming their product. Yeah, I don't really know how to answer that. Mert, you should jump in anytime you have an opinion too.
This isn't my show. But if you're inviting, then maybe I will.
Please do.
Jonathan is asking, what are some examples of small-scale aquaculture?
Yeah, good question. So offshore aquaculture has to be big to be cost effective generally. So we have smaller scale operations happening on land or close to land. If you think about being sited really far away, it's just a lot of money to get personnel back and forth. It's just a lot of logistics, and equipment is really expensive. So we have some smaller farms. There's a ton of catfish farming in states like Mississippi and Alabama, and those can be pretty small pond-based operations. In Louisiana, we raise a ton of crawfish, which is actually also aquaculture, and alligators. And you can see if you're building tank systems, it also depends on your purpose. So there's small family-run farms like shrimp farms and redfish farms in Texas as well. And also you have to sort of think about what's your purpose. If you want to sell that product, let's say for people to eat or something like that, you're going to need to think about your profitability parameters. But like I mentioned, these folks that are doing aquaculture for stock enhancement, these are, sometimes state-run programs. that's a different model, and those could be pretty small operations. And in Louisiana, we actually have a hatchery way up north in the north part of the state that does recreational fisheries like largemouth bass.
Perfect. This is kind of a related question from Melanie. Melanie is asking whether if the U.S. was to up its aquaculture game, quote unquote, would we have better success of sustainabilities in our ocean?
Yeah, so people should realize that so many of the players that are involved in aquaculture development, I think also consider themselves environmentalists, right? So I'm an environmental scientist and I am a huge supporter of aquaculture. It's what I'm devoting my life to, right? So in my opinion, there are noticeable benefits to using aquaculture as a source for food, right? We have a growing population, we need more food. And there are so many things we couldn't get into, but I've talked a little bit about water use, right? It's a low water input way to grow food. And it has other benefits as well, like fish are super efficient at growing based on the amount of food they eat. So for these animals that are in the water, if you think about an animal on land, they're fighting gravity and they actually expend more energy to grow. So fish are pretty efficient growers. And so for a lot of reasons, I think that aquaculture is a really smart way to move forward.
Joseph is contributing to your answer a little bit, and he says Florida pompano is an example of small scale aquaculture in Florida.
Well, awesome.
And I seem to remember that way back from my research days.
Yeah, Florida's a little powerhouse. Like Florida as a state has really gotten behind aquaculture, and they have a ton of different sorts of initiatives for aquaculture development, which is really cool to see.
That is very cool to see. Chardonnay has another question about the ecological effects that food can have on the surrounding systems. For example, fish species enter the surrounding system and the ecosystem utilizes the nutrients. Could excess nutrients become a problem?
Yeah, so excess nutrients, too much nutrients is a problem. Some is beneficial. If you think about like productive systems, like Louisiana is super productive because we have really nutrient-rich waters that support all these fisheries. But too much nutrients are a bad thing. I'll tell one cool way that people are combating this. So in offshore aquaculture farm systems, when you introduce feed into that system, the fish act in a way where they're feeding behavior. So you can actually see that they're feeding. And people right now are developing AI technology so that when that behavior changes of that huge cohort of fish and they're not feeding anymore or it shifts enough, you can tell that that change has happened. So, oh, okay, you know, whatever percent decrease in feeding behavior, and then they'll stop feeding. So right now, operators are eyeballing it with camera help and whatnot. But through those AI technologies, we hope that more of the feed that's going in the water is getting eaten by the fish and less is getting lost as waste, which is also good for your bottom line because you're not wasting money throwing feed in the water that the fish aren't eating.
That's great. Thank you for that answer. And I know I still have questions coming in, you guys, and they're great questions, although we just don't have time for them tonight. If you want to continue your conversation with Dr. Bockus, you can either email me and I can play the go-between and send Dr. Bockus your questions for her to answer, or you can email her directly. She did invite you at the beginning of the presentation to do that. Her email can be found on our website under the research link at the top, and then you go to faculty. And she, I think, is the very first one listed. So she's pretty easy to find if you want to reach out to her on your own. Otherwise, you have access to my email. So that brings us to the end of another great talk, Abigail. Thank you so much for teaching us what aquaculture is and all the cool stories that went into it, like food catching on fire.
Yeah, food catching on fire. Thanks, Mert. It was super fun.
You're welcome. And for the audience that are still here, remember, 10 talks that you attend will earn you a Research Vessel Pelican Challenge coin. For those of you who have attended every single talk so far, you're only 2 talks away from earning that challenge coin. So we hope to see you next week for Dr. Mary Miller's talk, who's been a frequent attendee of the talks. So we're really excited to finally get to hear from Mary. So yeah, next Thursday, 7 o'clock Central Time, register and log in for our next great talk. Good night, you guys.
Thanks, Mert.
Thanks, Abigail. Have a good night.